Welcome again to this video. This is our third video in our series of infrastructure as a code, whereby we've been looking at Terraform. Now, from our second video, we actually focused on the command basics, whereby we discussed the Terraform workflow. So Terraform workflow, basically we focused on the command basics, how to run Terraform commands, whereby we said you will have to initialize your Terraform working directory, which is just a directory that contains all your Terraform files. So we looked at the commands that we need to run if we want to initialize Terraform. So we looked at Terraform init, we looked at Terraform validate. This basically just checks the syntax. We looked at Terraform plan, which will create an execution plan for you. We looked at Terraform apply, whereby once you run Terraform apply, then the apply changes to reach the desired state, like based on your configuration. So once you run Terraform apply, it is going to build your infrastructure so that you reach your desired state. Then we equally also looked at Terraform destroy command. We looked at the Terraform destroy command. We also looked at briefly in terms of the Terraform configuration files. We said if you are writing a Terraform manifest file, the file needs to end with a .tf extension. This is the configuration file that is written in HashiCorp configuration language format. It is a .tf file extension, and that extension is human readable. And we saw equally how we can easily write our Terraform manifest file by using both our IDE, which was our VS Code, or we can easily go on the documentation, the official Terraform documentation. We are able to go there and look at the examples or copy resources from there and just paste them in our IDE. So as we go on, we will be utilizing both of those methods, whereby we will learn to practice to go onto the official documentation to get the official or write up Terraform manifest, but also we'll practice writing them so that it becomes like second nature to us. Now, so today we're going to move into our third chapter, which is just, we are now going to go deeper, a little bit deeper into looking at the language syntax, like how do we write. Like yesterday we saw when we wrote some manifest, like a manifest file, like just for an EC2 instance, right? We saw that we just wrote a resource block like that. We were able to create our resource by defining our resource, and that's the AWS instance, right? And we had to pass some arguments, like we said we have to pass our AMI inside and then the instant type, right? So we saw that we have to declare our resource. If we want to create an instance, we have to start with the word resource. So in Terraform, these are what we call blocks. So we did that, but today we're going to go deeper now into why, or the syntax of Terraform. Now, when we look at Terraform has what we call blocks. Now, we have 8 fundamental blocks that you need to know. These blocks are basically what makes the Terraform configuration language syntax, like how you write your Terraform code. So writing this Terraform code, you will need to be aware of 8 blocks blocks of code or 8 templates that you have to use. Now, the first one, we are calling it the Terraform setting block, right? We have the Terraform setting block. Then we have the provider block. We have the resource block. We have the input variables block. Then we have the output values block. Then we have the local values block. We have the data source block. And finally, we have the modules block. So as we keep writing our manifest files, our Terraform files, we do realize that we will be using or utilizing these eight blocks, but we will at least have at least two blocks for our Terraform to work. Like yesterday, we saw we utilize a provider block and a resource block when we wrote our script or our manifest file. When we were creating our EC2 instance, we realized that we had to provide we had to put a provider. Now this is a block. This is what we are calling a block. So a block, it has a type. You see, a provider block. A provider block is used to specify the provider configuration. So we have this provider block right here, and we are passing some arguments inside. Then now here, we also have a resource block. Now a resource block declares a resource of a given type with a given local name, right? With a given local name. So the name is used to refer to this resource from elsewhere in the same Terraform module, but has no significance outside the scope of the module. So that's why we had this. It is a type, right? It is a resource type. And then we have this as a reference name. A reference name. This name, it will be referred within the module. This is the name that Terraform knows about. So now this block of code is a resource block. It is identified by, it's beginning with the word resource. So this is a resource block, right? A resource block. Now inside of this curly braces from here to here, inside of it, this is what you're calling the block body. So yesterday we saw at least two of these. We utilized the provider block and we utilized the resource block. So today we are going to go a step further and look at these different blocks that we have in Terraform. Now, when you talk about a block is a container for other content, right? So for example, you'll have a block type, like this block type here would be like a resource. The name here would be like a resource. But then we have the block label. This could be like AWS instance, AWS underscore instance. This is the block label. This is the label. The block type, this is a resource block, right? Then we have the block label, which is AWS instance. And then we have another block label. This is the name, the resource name that is local to Terraform. Then we have inside here, this is what we are calling the block body. Now inside the block body, we have an identifier. This is like AMI, like what arguments, what are we passing inside here. So this is called an argument. AMI is an argument, but the value of this AMI is the expression, right? Is the expression. So we have arguments and we have expressions, right? Inside of our block body. So when you are writing like a resource block, right? A resource block, it will have two labels. It will have two labels. Now, these two labels, we have a resource type and we have a resource name. Then it will have arguments and it will have expressions, right? Inside of it. So a block has a type that is resource in this example. This is the type of block. It has a type. So each block type defines how many labels must follow the type keyword. So the resource block expects two labels. Like a resource block will expect two labels. These are the two labels that we are referring to, which are AWS instance and EC2 demo in the example above. A particular block type may have any number of required labels, or it may require none, as with the nested network interface block type. Like you can have a block that is nested, a block that is within a block that might not require any label, right? So after the block type keyword and any labels, the block body is delimited by, you have to put it in curly braces, right? Because you are passing like map values inside here. So after the resource and these two labels, then you have to put these curly braces, that opening and this will close, opening and that will close. Then everything else is now enclosed within these two curly braces, right? So within the block body, further arguments and blocks may be nested, creating a hierarchy of blocks and their associated arguments, right? So with that, we also saw that now we have what we call arguments. Arguments assign a value to a name, right? They appear within blocks. Arguments can be required or optional. So now we have these arguments. Arguments, they basically assign a value, right? They assign a value. So on the left side, these are arguments, but on the right side, values, these are what we call expressions. So expression, they just represent a value, either literally or by referencing or combining the values. Like now, as we will be looking at variables, so expressions can be like a variable. You can assign the value of that argument and pass it as a variable, right? Then attributes, they represent a named piece of data that belongs to some kind of object. The value of an attribute can be referenced in expression using a dot separated notation, like AWS instance .example.id. So I will quickly show you what an attribute is. So an attribute, if we have a resource, like we are creating an EC2 instance. Now, what we are inputting inside of our instance, like AMI and instance type, right? All these things we are putting, we are acting as an input. These are arguments that we are passing inside of the resource so that we create it. But once the resource is created, there are things we can output, right? There are things we can get, like if I create this resource, I can output, I can get an IP address, I can get a DNS name out of this instance that I've created. So what I'm getting out of the resource as an output, this will be referred to as an attribute, right? As an attribute. So therefore, for that particular resource, I can get an ID. I can get an ID, and how I will reference it will be the resource type. Like now, the resource type in this case, if I want to get the public IP of this, the resource type is AWS instance. Then it will be AWS instance dot. Then the name of the resource, which will be EC2 demo, then dot, what attribute am I getting out of it? So it will be public IP or ID. So I will show you guys all that real quick. But now just to go through, you can go through this. Now we have the identifiers, which is what we basically just mentioned here. These are just names to identify basically the expression. Then also in Terraform, we can comment just like in any other programming language, we can comment like lines. If you put a hash sign, it begins a single line comment ending at the end of the line. So in Terraform, you can also put these two forward slashes. This one also begins a single line comment as an alternative to the hash symbol. But if you want to do a multi-line comment, then you can use / then asterisk. So you start with that, then you end with a asterisk /. So once you put these two, so any code that falls within these two is basically commented out, right? It's basically commented out. So this is in terms of syntax. In terms of syntax and in terms of writing code, in terms of our blocks, just remember that we have a block type, then we have the labels, right? So if we look at Terraform, as we had said, we have these eight basic blocks that you need to be aware of. So if we go down to this block, the first block we said is our Terraform setting block. Now, Terraform setting block, it is basically a block that sets the required versions of Terraform and the providers. Now, after Terraform version 0.14, this Terraform block was introduced. Now, this Terraform setting block, as you saw yesterday when we ran our code, we didn't provide that Terraform setting block, but still our code ran. So in development, when you're just trying out, you can run your code without that Terraform setting block. So what this does is that it will always just download the latest plugins, okay? So if I run my code like this without the Terraform setting block, it is just going to, once I initialize and Terraform searches for AWS provider, it will just download the latest version of the plugins that are there. However, in production, as we will see when we are dealing with especially modules are versioned, right? They are versioned. And because versions in Terraform, versions change, right? Versions do change. Like today, you can have Terraform version 0.14. Tomorrow, after 2 weeks, that version will have changed. So what happens is that if you need to put the required version of Terraform, because it is going to determine how you write your code, because things do change. In Terraform 0.14, how the code was written, how you called variables was totally different from when it was updated. Because like right now, if we go on to, let me just go on to, let me search for Terraform. Let me see Terraform latest version. Terraform latest version. Let me just go to Terraform HashiCorp. So, like now you see, right now the latest version of Terraform is 1.1.4, right? This is the latest version. So on this particular block, this is the latest version. Now, I will show you like modules. So modules, when the community builds modules, they actually version them to work with a certain version of the Terraform code. So if you don't pass the required version, let's say the code that the developers wrote, they wrote it based on this 0.14. That was the kind of standard of how the code was written, how variables were passed and all that. Maybe it was 0.14 version. Now, if in your Terraform, if I don't pass this as a required version, right, what will happen is that once you initialize, Terraform will download the latest version. Now, once it downloads the latest version, then when it initializes your code, right, your code will fail. It will have an error because how that code was written is not compatible with the latest version that Terraform is now downloading. So with that said, it is going to throw errors to you. So in production, we always do what we call constraint. You put a constraint on the version that you want it to download. So if I put this Terraform block and I say the required version is 0.04, so what will happen is when I initialize, then what will happen? The Terraform, like when I initialize, Terraform will do what? It will go and look for this particular version, that particular version of Terraform, right? It will go and look for that particular version. So like right now, the latest is 0.14, but I equally have a 1.011, right, release. So what will happen is that Terraform will now go and download that version that you say this is the required version because my code depends on this. So we in production, remember, we need to set this Terraform setting block whereby we are putting our required version. Now, for right now, our required version is 1. The latest version is 1.114. Okay, so this is where we put our required version. But there is something we call how versioning works in Terraform is. Now, this first number is your release number, right? This is your release number. This second number is your major version, and this is the minor version, okay? So what happens is that maybe every 2 weeks, something, because the community is very active, they keep working, and maybe after 2 weeks, maybe this will change to maybe 1.5, right? A minor version will be, maybe they improved something in that Terraform configuration file, and therefore it might go to like 1.15. So when we do put a constraint, we want to constrain it like to a major version. So when you use this tilde greater than sign, you are saying that you're constraining it, you're constraining the right version, you're constraining to the rightmost value meaning now like here it is the major version. You're constraining such that it is going to accommodate any change in the rightmost value, okay? In the rightmost value. So that means if right now my Terraform version is 1.1.4, right? So I'm saying I'm constraining it to the rightmost value. So that means if it changes to 1.15, it will still be supported. 1.6, it will still be supported. 1.7, it will still be supported. But also, the rightmost value here is 1. So it means if the version changes to 1.2, right? Because the rightmost value here is 1. So if it changes to 1.2, it will still be supported, right? If it changes to 1.3, it will still be supported. If it changes to 1.4, because this is the rightmost value, all right? So I'm constraining it to the major version. But if I constrain it to the minor version, if I do like that, then the rightmost value is 4. So it means that the version of Terraform that will only be supported is any change in this rightmost value. And this one is the minor value, the minor version. So it means that the version of Terraform can only be 1.1.1 either 4 or 5 or 6 or 7. Now, all these are just minor versions. But if you have a major version change, like if it changes to 1.2, then the code will fail. Okay, so that's why now when in our constraint, we will actually just constrain it to 1.0, right? So that any change in the major version, right, in the major version, which is the rightmost value, it will still be supported, right? So this is now what the Terraform setting block is used for. So here we pass our required version, but we also pass our our required providers. Now, as we've said, how to find it, how to find like writing that, if you just go onto Terraform, you just type Terraform setting block. If you go into Terraform setting block configuration, right? Setting block configuration, then it will basically show you. It will basically show you like right here. It will give you an example. This is how we write the setting block. We have our Terraform, we have the required providers, AWS and all that, but we also pass our required version, required Terraform version within that. This is where we constrain it. Then apart from that, so you can just equally come to the documentation, right? Official documentation. You have the required providers. You can also pass the required version of Terraform right there. So if you copy that, then you can just paste it in your IDE. But equally, as we said, if you go onto your VS Code with a plugin, right? With a plugin, then if you type Terraform, this is now the Terraform block. You see, it tells you the block. Terraform block used to configure some high-level behaviors of Terraform. So if I select that, it is opening this. Now, in that Terraform block, if I click Control Space, then in this Terraform block, I can configure my backend, right? I can configure my backend. I can configure the required version. I can configure the required providers. So if I click required version, it is going to tell me what version is it. So in this version, the value, I can put tilde, I can say tilde greater than 1.0. This is the required version of Terraform. Then I can enter, then control space. Then I can configure my required providers. Who are my required providers? I had AWS, right? I had AWS as my required provider. So I'll put AWS, and then this required provider is a map. When, as we saw right here, the required provider is a map. And then the source, my required provider, the source is where I'm getting this is HashiCorp. How do you find it? If you go onto your documentation and just go to Terraform, go to documentation, right? Or let me say Terraform registry. If I go to the registries right here, if you go to the registry, then browse by providers. If you look at your providers, your provider here is AWS. So if you click on AWS, AWS, again, this is the official name of the provider, the official name of the provider. And then if you go on the documentation, Now it shows you like how you configure your provider. So for the required provider, AWS, the source is HashiCorp. So it will download from HashiCorp AWS, and the version of this is the latest version. The latest version for AWS right now, the latest version is 3.73. Oh, so we have all these versions. So now that where you can constrain it, you can say you want to download this version 3.7, right, or 3.6. But what we will do is that you can constrain it to the rightmost. So you put 3.0. So any major version or minor version, 3.1, 3.2, it will still be supported. So what will happen? It will always just download the latest version, anything 3 with any number here. So this is how now we configure our required provider, right? Our required provider. So I can copy that and I can go back to my VS Code right here, and for required provider, I can just paste that right there. I can paste that right there, right? And this is now I've now configured my Terraform block, whereby I have constrained. So I need to close this. I need to close that like that. Because this closes with that. This closes this, and this right here closes this. So now I've now put my Terraform block. But inside this Terraform block, we can also configure what we call our backend. Now I'll come to this backend. Backend just means you can configure where you want your Terraform to store the state file. Right now, as we were running our Terraform code, you saw that once I initialized and created plan, it was creating a state file on my local desktop, right? On my local desktop. So it was storing that state file locally here, right? So if I don't configure a backend, if I don't tell it where to store that Terraform state file, like storing remotely, like in an S3 bucket, right? And then it is going to store it locally on my remote server, or on my on my local computer, right? But if I configure a backend here, then it is going to store that state file. Once I run Terraform, it is going to store it remotely. It is going to send it to, if I configure, let's say, an S3 bucket, it is going to send that to an S3 bucket. So I can configure that backend. If you add a backend like an S3 for remote storage, then you'll need to configure this backend. You need to give it a bucket name, right? And the key, this is like the directory where you, inside the bucket, where it is going to store that state file. And then the region where you created the bucket, right? We know that you can access it. It's a global, is a global resource or service, S3, but however, you need to provide a region where you created it. And then the reason why we do that is because now we can lock it. And because it's regional, it is a global resource, then we are storing that state file in a distributed environment whereby different engineers from different countries, different continents, as long as they have access to that S3 bucket, they're able to have access to our state file, as we will see. So within that Terraform setting block, you can configure your backend. But for now, we will leave it at before we configure the backend, we will use our local storage, right? Local storage meaning we won't configure any backend here. So once we initialize this Terraform will just download, and it will create our resource, and it will save the step locally, right? So that is the first block. That is the Terraform setting block. Now, the second block, as we say, now this first block, sorry, it doesn't have any label, right? Your block one Terraform setting block does not have any label, right? Now, the second block is our provider block. This is what we saw. Our provider block will expect one label. One label, this is the name, the official name of the provider. Then inside of our provider block, we can pass our credentials. These are the credentials that we are passing. As we saw yesterday, I can pass a profile inside of my provider. Then also inside my provider block, this is where I'm configuring my region, right? I'm passing my region inside of this provider block. So this is the second type of block that you need to be aware of. So we have the setting block, Terraform setting block, and secondly, we have our provider block. The third block is our resource block. Our resource block will expect two labels, right? We'll expect two labels. Now, these two labels, the first label is your resource type, like the type of resource that you want to create. Do I want to create an S3 bucket? Do I want to create an EC2 instance? Do I want to create? And if you go on the registry, and you want to search for, let's say, an EC2, right? EC2, a resource under EC2. So you see, you can create an AWS, you can create an AMI, you can create AMI from an instance, you can create EBS snapshot, you can create EBS volume, right? You can create all this. And the naming convention, as you see, it starts with AWS _, then the name of the resource. If I want to create an elastic IP, if you open it, then it shows you, it will require any resource block, it will require two labels. So if I want to create an EIP, then it will start with a resource, then I'll have AWS _EIP. This is the resource type that I'm creating. Then this is the resource name. So the name of this elastic IP, it will just be LB, right? Then this is the block body. I'm passing an instance whereby I want to attach this elastic IP onto an instance. And on this instance, I have an argument, right? I have an argument, but then here I have what? The value of this particular argument that I'm passing. I want to attach. This is the ID of the instance. I'm attaching this EIP on this particular instance that has that particular IP. So I'm passing all these arguments. Now, with that, while you are on the documentation, now here we have what you call arguments and attributes. So arguments are what you can put into it, right? It is what you can input into the resource. But if you scroll down, you have attributes. So attributes, this is what you can output, what you can get out. If I'm creating an EIP, right? The attribute is I can get the ID, I can get the private DNS, I can get the private IP, I can output DNS, I can output tags and all this. So you always look at the arguments and the attributes for what you can get out or what is allowed to put in. So if it's an instance, AWS instance right here, and you look at the arguments, so you can put in all this availability zone. You can put in the core CPU count. All these are basically arguments. But as you scroll down, and all this is alphabetical, or as you scroll down, now what can you output? If now I want to look at my output, I'll look at my attributes. So attributes, I can get the Amazon resource name after the resource has been created. I can get the private DNS, I can get the public DNS, I can get public IP, I can get tags, right? I can get outposts, Amazon resource name. So all these under the attribute, these are things that now I can get out after my resource has been created, right? So once we go back to this, we see that now that is how we these are the labels and these are the inputs into our resource block. Now the fourth block is a variables block. Now a variables block, we are able to input variables block. We are able now to define different attributes, right? We are able to define different attributes, right? And arguments, we are able to define them as variables. So if we want to define a variable, then we are going to use the variable block, right? So it will start with the keyword variable. Then the variable block will only require one label. It is just the name of the variable. If I want to write a variable for the instant type, so the name of this variable will just be instant type, and therefore I can make reference to this variable, or I can call this variable just by its name, right? As we will see. So we have the variable block. I can put a default value, I can put description, then I can put the type. So if we go to, let's say we go to our VS Code, and we want to create a variable block. So once you type the word variable, right? Variable, it is a variable block. Right here, you see it only requires one value, just that the variable name. So I can say instance underscore type. This is the variable name. Then now inside, if you control space, then this is now how you can define it. You can put description, you can put default, and all this. So you can put all these things inside of the variable block. So based on your use case, right? Based on your use case. So we can do that. So so we have this variable block as the fourth block that we will be using. Now the fifth one is an output. Now this is now when I was talking about the attributes, what we want to get out of our resource that we've created. So we can get an output. Let's say, for example, we are creating an EC2 instance and we want to get the public IP of that. So I can use an output block, right? And the name of what I'm getting out, I can give it any name, right? But the name, as we will see when we'll be talking about variables and how to write variables, this name must be descriptive enough so that when somebody reads your code, they actually know the intention. So like right now, I want to get the public IP of my instance. So therefore, this is the name that I'm going to give it. Then I can give a brief description. This is the EC2 user public IP. And then I need to put now the value. So the value of the public IP, the value of this public IP, it will be the resource type I'm getting it from, this AWS, this instance, right? It will be the resource type I'm getting. The resource type is AWS instance. Then you put dot. Then the resource name, let's say, because if you are creating like 3 or 4 instances, so they will all need to be identified and they will all have a unique IP address. So that's why now you have to reference the name. Which instance are you referring to? It is an instance with this name. So this name is local within Terraform. It is a local name, right? So for referencing, so I need an IP address for this instance, this resource. So it will be my resource type, which is AWS instance, dot resource name, which is class 25, and then dot the attribute. What do I want to get out? What do I want to output? So if I'm in my EC2 instance, what do I want to output, right? This is my resource. So I go to my attributes. This is what I want to output. My attributes, what do I want to output? I want to output the public IP. So therefore, this is what I write. I want a public IP. If I want to output a private DNS, right, then I'll write .private DNS, right? If I want to output the Amazon resource name, then I'll write .arn, right? If I want to output tags, right? If I want to output tags, then that's what I'll like. If I want to output volume ID or device name, then this is what I need to write as an attribute. So if I want the private DNS, let's say private DNS, so I can copy that private DNS, then I will go to my output block. And now here, instead of public IP, I can put .private DNS. So this is an attribute that I'm trying to get out of the instance that I'm creating. So I'm using an output block, right? So you can, right now we are doing public IP. So I'll keep it at public IP, right? So this is the fifth block. Now the sixth block is local values. Now local values is basically used if you have like a long name and you don't want to keep writing all these long names to reference within Terraform. So you can create a local block and define that long name in the local block. And therefore, let's say if you had, this is a bucket name prefix, right? So if the name of the bucket would be this long, right? And maybe it has both the app name, it has the environment name, then maybe the name of the bucket itself. So the name can be that long. So I can define a local block, locals like that. And then when I'm going to reference it, I will just reference like bucket name, bucket underscore name equals to, and then now I just reference locals dot, let's say if this was just bucket name, right? If this was just bucket name, I've just said the bucket name equals to, I'm assigning this long name to this variable or to this variable. So when I want to get my bucket, the name of the bucket somewhere else, now I can reference just locals block, then dot, or this can be just the name, right? So I can just say locals.name, right? Locals.name. So when I say locals.name, then it is going to read from this locals block and it's gonna substitute this name with all this. So this could be a very long name, right? But I don't want to keep referencing like right here, I'm trying to create an EC2 instance and maybe I want to put a name for something. I don't want to write this whole name right here. So what I do, you create a locals block. This is something that you can reference internally. You create a locals block. Then when I go to reference it, I'm just referencing this block. I'm just saying locals dot, what do I want from this locals block? I just want the name and it will substitute this name with the value, right? With the value, because this is like a key value pair. So it is when I put the key, it is going to substitute that key with the value of the name. Then The seventh block is what we call a data source. So Terraform also does have what we call data sources. So data sources, if you look at data source, let me just say data Terraform data sources. Data sources, right? Data source configuration. So a data source, it allows Terraform to use information defined outside of Terraform. So defined by another separate type of configuration or modified by function. So like if I want a data source, right? I want to get some information. Let's say I want to get some information about an AMI, right? An AMI in Amazon, in AWS. So I can use a data source, so that this data source, it is going to go into AWS and find out information about a certain AMI that I want. Then it's going to bring this data back to me to use it in my code, right? So that is what we use data source. I can equally use a data source. Let's say, for example, I have another state file. Like I have like Terraform, you've configured something like a VPC, which is your network, as we will see. You can configure VPC, then once you configure the VPC, it will have a state file. And then now, instead of you now creating another VPC to run, to be able to provision your resource, because as we say, if you're creating something like an EC2 instance, it needs to be created in a certain VPC. If I don't pass a VPC here, it will look for the default VPC. So this instance will be created in the default VPC. In your account, every region will have one default VPC. So if you don't pass a VPC, this resource will always be created in the default VPC. Now, if you don't have a VPC, let's say you accidentally delete your default VPC from your account, once you run this particular code to create this resource without a VPC, it will give you an error. It will say no VPC found. A resource cannot be created without a network. So that's why it will be important that you have a default VPC. But what I was saying is, so let's say I have a VPC that was already created, and now I want to use that particular VPC, and I want to create my instances inside that other VPC that was already provisioned and it has its own state file. So what I can do is I can now use a data source, right? I can use a data source to get the VPC ID from a different state file and bring it so that I reference it inside of my resources, so that now this resource will be created inside of the other VPC, okay? So all these things we will do demo and it will make sense. But right now, just remember the blocks that we are talking about. So you can use this data source block, right, to do that. And this data source block, it will require two labels, right? Two labels. The first label is your resource type, right? What kind of data do you want for what kind of resource? I want data for an AWS AMI, or I want data for an AWS instance. I want data for that. Then you can give it a name. This is the resource name, the name that will be local, that you'll be able to reference, right, within Terraform. So if you go onto the registry and you look at data source, at data sources, let's say you go to the registry, registry, you browse by provider, you're looking at AWS. This is what and you go to documentation, right? Documentation, and now you look at, let's go with something that we are familiar with for now. Let's look at EC2. Now in the EC2, you have resource. These are resources. This is what you create. But as you scroll down, then you have data sources. So if I want to get data for an AMI, right, then I need to look at the data source. Now, if I want to get data for just an EC2 instance, I will need to look at AWS underscore instance, right? So once I open, now I can get like the instant ID. Let's say I want to get the instant ID of a certain instance, right? I want to get the data. So now I can use this data block and I can use filters. I can use some filters so that it outputs for me, it brings back for me that particular instant ID that I want. So it also tells you now the arguments. You can put instant ID, instant tags, filters, right? You can put all these arguments. And this attribute, this is what you are able now to get out of that data source. You are able to output the ID, AMI ID, the Amazon resource name. You are able to output all this out of that particular data source. So you are able to return, you are able to make an API call to AWS, and you are able to return this data, okay? So now this is what we call a data source. So you can use data sources to get information. So this is the seventh block, right? The seventh block. Now the eighth block is what you call a modules block, right? So for a modules block, we will be writing modules. Now a modules block will only require one label. Now this one label for modules block, it is just the name. It is just the name that you're giving that particular module. You can give it any name. This is a name that is local within Terraform. Then, as we will see, now we can write our modules. We can write our own custom modules, or we can go onto the registry. We can go onto our registry. We can go onto the registry. If I go back, we can go to our registry. Actually, you can go back to registry, and now you see we have modules. So you can equally download modules here. So if I search for VPC, for example, if I search for VPC, okay, modules, if I search for VPC, a VPC module, right, then you see this is like the example of how you can write it. It starts with the word module, right? It starts with the word module, then the name, which is just an identifier, then the source. This is where it's coming from. So we'll go through all this and what inputs you can put within a module, right? So basically these are the eight fundamental blocks that you need to know. We call them the top level blocks. So when we are writing our Terraform code, as we go through it, you realize that we will be utilizing most of these blocks. We will use our Terraform setting block. We will use our provider block. We will use our resource block as we create resources. We will use our input variables. As we start next videos, we look at variables. We will be looking at variables block. We will get outputs from our resources, and we have to use an output block. We will define local values, right? Then we will use data sources. we will use data sources to get information from AWS to inject them into our code. Then we will also use modules. We will be writing modules, custom modules or official modules from the registry. So these are the 8 fundamental blocks that you basically need to know. And we've looked at arguments and expression, like what you are passed in. So if you can master, just if you are using your VS Code, it will be very easy as you write them. But learn to always look at the documentation. Go to the documentation, because sometimes when you look at your VS Code, sometimes maybe the extension you install, the extension can expire. It might not have all the functionality, everything that you need. But if you go to the official documentation, you'll be able to get more information. You'll be able to get more information on how to write your code, on how to pass different arguments. So always go back and forth, look at the documentation, then look at what the extension is doing as you write your code. All right. So with that, I will go to this manifest, and here we are just going to try and just run, or just initialize like what we just did. So here I have this Terraform block, right? I have my Terraform block where I'm defining my version. Then I have my provider, and as I said, if I don't pass a profile or credentials here, it is going to use the default profile or default credentials, which is right here. Then I just want provision a simple EC2 instance, right? I'm provisioning an EC2 instance, and this instance, this is the name of the EC2 instance. Then I've passed an AMI Amazon Machine image. I've passed it there. Then the instance type is T3 micro. Then another thing is, when we are creating an instance, we are using user data. You can use user data, right? User data is, you can put a script, you can pass a script so that when the instance is creating and it's bootstraps, when it bootstraps, what happens is that it runs a script, right? It runs a script to bootstrap it. So you can pass a user data, because this is an argument. When you look at your registry, and you are looking at your instance, EC2 instance, and you look at your arguments, like what you can pass inside of your EC2 instance. So if you scroll down, you will see you have user data. User data. This is an argument. You can pass user data to provide when launching the instance. Do not pass gzip compressed data via this argument, right? So you can use user data. So for this, we are in this instance, we are now going to pass user data. And for user data here, we are using what we call a file function. Terraform, we are using a file function, and we are passing a script. We have a script here called app1 install, right? We are passing this script, and how we are passing it, we are saying we are passing this file function, and this script is within the path.module. Now, a module is any group of Terraform files that are within a directory. That when you initialize, these basically files are like they're being initialized together. It's a combination of variables, outputs, and all that. So they are within one working directory. So that makes your root module, right? So this script is within the path of my module. So this is how you reference it, right? You reference it. So I'm using a file function to attach it to this particular instance as I run it, right? This is the script. Now on this script, what I'm doing is that on this script, I am updating my server, and then I am installing HTTPD, right? Installing HTTPD, and then I'm enabling it, then I'm starting it. And then I'm echoing welcome to Landmark Technologies, right? Into the var www HTML index, right? Then I'm equally making a directory app1, and inside that app1, I'm also echoing this welcome to Landmark Technologies, right? Terraform demo. Then I'm also running a command to get the metadata of metadata. This is the command, AWS command, to get the latest metadata of the instance that it has created. And it will be inside the directory app1 metadata, okay? So I'm running this script, I'm bootstrapping this script on this instance as I created, right? As I created. That is your script, that is the instance, and this is my Terraform block, okay? My Terraform block. So this is my IDE, right? So what I can do is that I can use this VS Code. I can use this VS Code, and what I can do is I have my provider, which I've already set. I have my provisioning into US West 1, US West 1. This one is being provisioned into US West 2. If I look at my instance, my AMI, so let me just update. This AMI belongs to US West 2. So let me copy this AMI. This AMI is for Red Hat. Let me copy it. Then let me go to my VS Code, and let me just update this AMI. Because remember, we said AMI is region specific. So right now this was being provisioned in US West 2. So that AMI is from US West 2, right? US West 2. So I can do that. US West 2. My region is US West 2. US West 2. And then instant type, I can leave it at T2 micro, and then I have to pass this user data. I can copy this user data, copy user data, then I can paste it. I can paste it right there. User data, that's the file function. But then I now need to come right here and copy this up, right? I need to copy that file, then go here inside this directory and paste it. So inside this directory, I need to create a file. I'll just create a file, and the file, I'll just call it app1 install.sh, install.sh, right? Once I open it, then I'll copy this script. I'll copy the script, and I'll just paste the script here. So now this is my script. So I have the script and I have my provider. Okay. So now with this, what I can equally do is that I can now separate. I can create another file. So in this, I can create another file and call it versions of my provider, right? So I can create a file here and call it versions of provider. Let me just say provider.tf, right? Provider.tf. Then inside this provider.tf, I can go and now cut this Terraform up to the provider. I can cut it from there and put it inside my provider, right? Inside my provider. So right here, and I have my file that just has to do with my provider. It is set right here. If I go right here, I just have my file to do with any resource. So if I want to create any resource, I can put it within this. Then within this same directory, same part of my module, I have my script, right? So let me go to my terminal. So if I now go to my terminal, if I do pwd, I'm in my Terraform, that particular folder. If I ls, I have these three files in there. So what I need to do is I need to run Terraform init. So once I initialize, it's first initializing the backend. It's gonna initialize my backend. Okay, it's gonna initialize the backend. It's a while. Initialize the backend. It's now downloading the plugins. Now it has successfully initialized. So then I can run Terraform validate, just to validate, to make sure that everything is syntactically successful. Then I can run Terraform plan. It's gonna give me this error about the provider, like we saw yesterday. So what I can do is that I can reset my credentials. I can reset my credentials by running this command. Yeah. I can reset my credentials. Just run that command. Then I can run my Terraform plan. Once I run the plan, now you see it is now going to create for me this particular instance. It's going to create for me this instance. And I'm also using passing user data. So once it creates that instance, now I can run Terraform apply. Okay, let me just do Control L. Let me run Terraform apply -auto -approve. Just auto approve it. So auto approve it, and then it plans now to create that instance. Okay, so it's now creating creating the instance. So if I go onto my AWS in Ohio region, I'm creating it in what region? In my provider. I'm creating it in US West 2. US West 2, that's Oregon. US West 2. So it has finished creating. Now in US West 2, now it has just created that my first EC2. This is the tag that we had put on our. This is the tag that we had put on our EC2, right? My first EC2. This is the tag. It's a T2 micro that we had put on that EC2. So if I look on my console, my first EC2, it is still initializing. So it is still bootstrapping the script, right? So it is still initializing. So once it initializes and finishes, then what we will do is that we will go now on the browser. We'll use the IP and see if our script was bootstrapped correctly, right? It's still initializing right now. It is still bootstrapping. So we will go on our browser, and what we'll be looking for is in this particular script. In this particular script, we echoed landmark technology, which in our index.html. So if we go on the browser, we expected to see that. Then if we go into the app one, then we are expected to see welcome to landmark technology Terraform demo. Then if we go to index.html, we're supposed to see the metadata. So let's see if our instance, it is still initializing, it's still bootstrapping. Now it has just finished. So if I go here, like copy my IP address, I just enter ransom for 80, continue to site. So you see, welcome to landmark technology, right? Welcome to landmark technology from this is from this first echo, welcome to landmark technology. We just echoed in the index.html, right? But now if we go into the app one, right? If we go into the app one, let's say we go into app one, then we will see, and it's a different color, right? It created this directory, app one, welcome to landmark technology, Terraform demo, application version 1. So we see that, but also we equally, inside this app one, we equally had a metadata.html, right? So if we go into this metadata.html, copy, which is inside app one, if we go into app one slash metadata data.html, and then we will see the metadata of our instance, the architecture, the account ID, availability zone, US West 2A, the instance ID, This is the instant ID that. So this is an API. It has queried the API, and now it is returning this. So from this, we see that our script was bootstrapped, and our script basically ran. Right? Our script was bootstrapped and ran. So here we see we're able to use Terraform. We were able to use Terraform to provision our resource, right? To provision our resource, but also we used the user data, and it was able to install a script, right? So with this, we'll come to the end of this video. At least today, we've seen all the different blocks that we are able to use. We're able to provision the EC2 install. We're able to use the user data. So in our next video, we will be looking at now how we can use variables, right? We'll be looking at how we can use variables. So we'll be looking at setting, and we'll have like a project to do, like create our setting block. Once we set it, we'll have a project to do, and then we will look at now how we can use variables, to do this. So with that, I will just do Terraform. Once you're done, I'll just do Terraform destroy dash order approve. Terraform destroy dash auto approve. Okay, then it's now going to destroy everything, right? It's going to destroy my my instance. Destroy my instance, and now if I go to my browser and try to refresh it, this is still in cache. It's still cached, so that's why you can still see it here. But right now it is trying to search, but very soon it's going to lose that. So if I just enter again, so site is not found. So the instance has been deleted. Now it can't find it. All right. So thank you very much for watching, and we'll see you in the next video. Thanks. Bye.